11, there's actually an application that takes us back to the previous chapter, chapter 10 in network problems. It's a very similar problem. You'll notice the moment you see the diagram, which I don't have here. Yeah, I don't. But you're going to have the nodes, the circles, and all the branches connecting those circles. But now we're adding more components to it. We're adding cost, and we're adding the capability of turning on or off some of those branches. I put the switches here so you remember what I'm talking about, that these are the switches. This is what's going to turn on and off your production. But it is kind of not simple, but obviously, as you can see, it's going to take time to build, right? But it's very similar to the ones in chapter 10, just with the added component of cost and capacity and demand. If you think of capacity and demand, is supply and demand, is what comes out of one place and what is required from the other place. And in this case, we have plants in Detroit, Toledo, Denver, Kansas City, and St. Louis. And I always have someone in my class telling me that I don't pronounce St. Louis. Some say St. Louis. My understanding is St. Louis, so you can laugh about that. And we have distribution centers in Boston, Atlanta, and Houston. And if you think about this for a second, this kind of takes us back to the conversation we had last week about Amazon and distribution centers, logistics. So you have stuff in plans that need to go to 3 different places, and each of those places have a different cost and a different demand, and each of the plans has a different production. I'm sorry, and this is huge. I forgot to tell you one little piece. St. Louis, this is why we don't have. I'm looking at the problem right now, and I forgot what I was gonna say. But St. Louis, it's already built. You don't have to build it. It's already built. You're trying to decide whether or not to build the other 4. That's what the key. That's one of the key concepts in this problem. That is why I have 4 plants: Detroit, Toledo, Denver, Kansas City, that we are figuring out. We're trying to figure out whether or not we should build, and then we have St. Louis, we just already built. That's why I only have 4 switches here. The switches are for Detroit, Toledo, Denver, and Kansas City. St. Louis is already built. I can't turn it off. Not in this problem, but maybe in another problem. So you're going to have your constraints down here where each of them, so it's going to show you that Detroit, you can, even if you, what this means, right? This means that if Detroit ships to all 3 plants, they cannot produce more than 10. That one there. Et cetera, et cetera, et cetera, et cetera. Look at this setup now. See that? See, if I produce it, that will be 10, so that cannot be more than 10. And then I have the capacity demand here. I'm sorry, the demand for each of the plants over here. So, for example, number 5, which is St. Louis cannot take in more than, Boston cannot take more than 30 units. According to this problem, I have an equal there, so I guess, oh yeah, it has to be equal to 30. That is, you cannot have too little or too much. It cannot be 29 nor 31. It has to be 30. Okay. Now we're gonna go to solver and look at the setup. I'm telling solvers, yeah, I have my constraints and all that. Those 2 over there. That's just the basics. But then I'm telling solver that these are here the solutions. They have to be integers, that I cannot have half whatever this is, half tons or half whatever shipped. They have to be whole numbers. And I'm also telling Excel that these 4 switches down here at the very end, those are binary. Those are zeros or ones. Okay, and for a change, we're minimizing because this is cost, it's not revenue. We're trying to minimize the cost of shipping all of these units. So we're going to hit solve. And that's your solution. Kind of a weird solution, right? Well, it makes sense. Solver is telling you not to build Detroit, not to build Toledo, not to build Denver, but to build Kansas City. That's why we have a 1 here. Kansas City is number 4. And because St. Louis is already built, you can use St. Louis to ship some stuff. So what's the pattern? What are we shipping? Well, this is what we're doing. We're going to ship 20 from Kansas City to Atlanta. That's Atlanta. Number 2 is Atlanta. And from Kansas City, we're going to ship another 20 to Houston. Yep, that's number 3. And okay, what about Boston? St. Louis is going to take care of Boston, and St. Louis is going to send all 30 to Boston. As you can see, we don't have a mixed answer here, a mixed case where Kansas City and St. Louis will both supply the same distribution center. That's just the way the problem is. And the total cost would be $860,000. So the cheapest way to ship, to make sure that all those distribution centers have what they need, would be to build Kansas City and to ship 20 from Kansas City to Atlanta, 20 from Kansas City to Houston, and use the existing St. Louis plant to ship 30 to Boston.